Hello.
Hello.
Hello. Good afternoon from Nigeria.
Yeah. Good evening.
Yeah. Wow. How has been
Yeah,
the-
I'm good. Are you? Oh yeah, I'm good. Are you?
How is Sunday in China?
Oh, boring. We don't have any place to go.
You don't have
We're
any.
always in the yeah. So we are just in the room. It's like a normal day.
Wow. Just resting today, she.
Oh yeah, yeah.
But there's no work now.
Oh no, not really.
All right, no problem. Let's continue. Let's dive into.
Oh okay. Yeah.
I've not even opened Solidworks.
Okay.
So definitely we'll be starting our class on assembly today, and promise to be interesting. Sha.
Oh yeah, yeah. At least
Now,
that one is quite interesting.
all the part has been on. We have parts that we can use to. I will be sharing one of my work first so that we can walk through it. We'll definitely do one together, then I'll give you some also to do in this class.
Oh, okay.
We'll start from there. SolidWorks assembly is just about bringing the parts together with a certain mate and mate features. We can actually assemble these machines together and see how they are going to look like in this sense. That's one of the added advantages that SolidWorks has over AutoCAD.
The others.
Yes.
Yeah.
AutoCAD, you have to imagine every of the whole machine and do all of them in the same place. But in SolidWorks, you have opportunity to assemble them together and see how they work.
Yeah.
So here this afternoon, we'll definitely be assembling a machine that I built just of recent. It's a brake pad. There's a brake pad in a car, in an automobile brake pad. The machine is designed to produce brake pad. And it was built and fabricated by me also. So it's one of my recent work. We'll be looking at design on SolidWorks, how it's going to work, and we'll be assembling them together on SolidWorks. So a little difference now is if we do Control New, we're not going to be clicking on part again. So we have graduated, we are moving to assembly now.
Yeah.
So I don't know if I can easily see the pictures of the machines in real life. Maybe I can share it. Let me see if I can get the picture. I'll share it while we're still. Okay. See, I have a complete. Okay. Can just share. Okay, I think I have one I can share now. Though that's when work was in progress. So I believe is my screen visible.
Yeah, I can see. Okay.
So this is how it looks like. Though that, when it was not painted, sure. That was how the machine looks like. So these were the individual parts. Okay. That's it. So that's what we'll be looking at this.
It's for
The very simple process. Actually, in Assistant, I've not seen such a machine before. I just watched some YouTube video and I come up with something that should be able to produce brake pad. So, and that's it. And it was tested, it gives certain results. But the aim of the work was just to actually produce a machine that will be able to produce brake pad. All the old composite mixtures that will give us the right quality and the right quality in terms of abractions was not my concern. My concern is this machine will be able to produce brake pad, and that's all. So if you open an assembly as new one like this, then it will tell you that to begin assembly, you need to actually bring in a part. In most of the cases, I would suggest that we bring in the most fixed part. That's the fundamental fixed part. That's like the frame. I always suggest that that's the first thing to bring in. So I will go to, and it's always good now for the purpose of, it's always good that we have all our works in a folder that we can easily reference. So I have the page, I'm bringing it in now.
Okay.
So this is the base of the machine. This base actually houses the heating elements, houses every other electronic control circuit that's supposed to monitor the temperature of the process design. So once you bring in this, the very first component you bring into SolidWorks, SolidWorks automatically thinks that that should be your fixed component, like a frame. Like in maintenance of machine, there is always a link, a member called the fixed link. Like when we are talking about 4-bar mechanisms, 3-bar mechanisms, and all of them. So there is a link that's always fixed, upon which every other thing moves and rotates relative.
Will be added. Sure.
That is. So the very first one brought into SolidWorks assembly environment, SolidWorks automatically imagine that that will be your fixed link. So I want you to carefully observe it. You see F in the bracket.
Yeah.
So that F means that this component is actually fixed. And you can see it's fully defined. So it's possible to have an assembly that is under-defined, over-defined, and fully defined also.
Okay.
So it means it's fully defined. But there is a problem. The problem is, and many people don't know this, and this gives their work a bit of issues later in the day, which I want to point out now. As your part has the front plane, top plane, and right plane, so assembly also had its own.
Same. Yeah.
So it is very expected of you that the very first thing to do is once you bring in your fixed frame or the fixed lane, make it float. Float means that you can now move. You can see that that F has gone out. I'll repeat this procedure again. I can do it anywhere. You can make anything fixed. You can make anything fixed. So it's fixed back. Float. It means that you can now move.
Yeah.
Now, what I want to do now is to ensure that the front plane of my machine, of the very first part, align with the front plane of the assembly. Align with the top plane of the assembly and align with the right plane of the assembly. If you don't do that, by the time you want to generate your drawing, you might not notice any problem here. But by the time you are trying to generate your 2D drawings, then that's when the issue now shows that it wasn't properly aligned.
Okay.
So that's so what I will be doing now. One of the critical things in assembly environment is actually called mate. Mate means that how these components will actually be brought together in order to achieve synergy between them. So mate is the name, is the term used of how they will be aligned together. Of course, you have edit component, insert component, mate, and this. So we'll be doing a lot of mating along this class. So we'll start from standard mate, we start to advanced mate, we start to mechanical mate, and every other kind of mate system. We will touch all of them in this class, and look at exploded view, look at assembly features like adding belts, adding chains, when you need such kind of drive. So a whole lot of things will definitely be dealt with here. So let's start with a very simple mate. So the very, very basic mate is actually called the coincident mate. Now I have this surface and I have this surface. It is my intention that this surface touch this surface. So to make them coincident, to touch each other. That's what we mean by coincident mate. So we can definitely use this kind of mate anyway. My aim now is that the front plane of this minute component and the front plane of the assembly are coincident. So let me show you the front plane of the assembly. So this is the front plane of the assembly, while my component had his own front plane here also. But the difference. So I'll click on the very first front plane. It will show on the mate selections. You can see mate selections here. So the front plane I choose, it was there. Then the second front plane of my material. So you can see we have front plane at base in assembly 1 and front plane that doesn't have anything. It means that it has coincident, it automatically recognizes that I need a coincident mate by itself. So if I'm okay with that kind of mate, I will mark it and say yes.
Okay.
Now, again, let me stop a bit here so that I'll still make everything clear. Now, because there are 6 degrees of movement, freedom, 6 degrees of freedom for any component, which is translations along the x-axis, translations along the y-axis, and translations along the z-axis, including the rotations along all these 3 axes, making 6. Now, because I have constrained the front plane of this guy, so it cannot actually move along the front plane again. But I will do the top plane now. Top plane mate. This is also the symbol of mate. If I don't want to go there, go and pick mate. So there is a symbol for mate here. So I'll just click mate. That's the top plane. Then with the top plane of the material, mate. Now that I have 2 degrees of freedom aligned, so I expect this guy to only move this way. Cannot move backward like this again. Likewise, it cannot move up and down again. Now, the only movement it has now
is along.
It cannot move like this again.
Yeah.
Because I have mated that to a standard reference plane. It cannot move like this again. Because I've mated the front plane. Because the front plane is here. The front plane and the front plane of the assembly is here. So since they are in the same positions, so this cannot happen again. The top plane and the top plane, let's say this is the top plane of the assembly, this is the top plane of the material. So since I've mated them, there cannot be up and down movement. So the only movement that is permitted now is translations along this. So that's the last one now. I want to stop that movement now. So I will hold the right plane. The relevant thing to do is to make the right plane with the right plane of the assembly. Then you see the base shifting to the right plane. You see now, this is where somebody that is not an expert in Solidworks will definitely start having problem when it comes to assembly. Because you are just selecting any mate, any plane that you are starting your work from. When you get to assembly, then to easily make this thing work together, now becomes a problem. So, but if you have start all your drawings, all your parts from a very standard mate, where it's very, very easy to look at, then it becomes so. Now, let me show you what that simply means. Like now, if I said fuel, like I need a front plane, it just corresponds. I need the last plane, I need the top plane, I need the bottom plane. Everything will just be working in the way they're supposed to be. But if you have used a wrong plane, then you now have to be taxing your brain on
turning it yourself.
Where should I meet this front plane to? With the plane of the assembly, come to this, come to that. No, you don't need all those steps. If you actually done the work, that's the reason why we spend a lot of time doing parts, because the secret to Solidworks is actually the parts. If you get your part very well, then your assembly should not be a problem. So the next thing that I want to introduce here is the supporting columns. The 4 columns that carries the whole stuff. I want to bring them in. So I'll go to insert components. I will definitely be doing a bit about this. Insert component, new part, new assembly, copy with mate. I will explain each and every one of them. But what we're using now is insert component. And we'll use all of them along this class. Now, insert component is there's a component, there's a part you have designed before. You can bring them in, insert them into your assembly. That's what it means. Now, there is a type of what we are doing now is what we call bottom-up assembly systems. There's something called top-down assembly system in which all your parts is being designed in assembly plane. It's highly possible. Now, when did you need that? You need that when you want an external referencing, which I can do here. What did I mean by that? Along the line, I will demonstrate one for you. This is the O of my concern. Let's say I don't want to be measuring this O because the part that is coming in is supposed to enter this O. So if I want that, if this circle change, the part should change. Again, let me explain again. There is a hole somewhere. A shaft needs to come into the hole, but they're supposed to have a certain fit in between them. Let's say exact diameter. Yeah. So, but you don't want to keep. You know that along the line in progress work, if peradventure you might change this circle, you might change this diameter. So you want the parts, the corresponding parts, to take order from whatsoever you are doing here. That kind of thing in Solidworks is what we call external referencing, when the part is changing as a result of another part changing with it. That's what we call external. If you do a new part and you base it upon this diameter, if this diameter changes later in the future, maybe you are doing another work, it will definitely take order and change to it. So that's another. So that one is called top-down assembly systems. So what we are starting with bottom-up assembly systems. So that's when we'll be doing that. New assembly. New assembly means you are actually bringing a sub-assembly into this. If I'm designing a whole automobile, a whole gearbox itself is an assembly. So it's permitted for me to bring assembly in assembly. Then that will now become a sub-assembly of a whole assembly.
The new one. Okay, yeah.
So it's highly possible. Let's say I have an assembly. I have jobs like that. That I have. Yes, I can hear you.
Yeah, okay.
So I have jobs like that I have to bring in assemblies into assemblies to make it work. Like the job I sent to you, that tree climbing. That tree climbing machine actually has a gearbox. The gearbox itself is an assembly that I'm bringing into an assembly of the machines. And the moment you are actually doing that, the only implication is that the ability of your system to analyze things, it becomes a complex thing for the system to go about. But it's not, if the system has a very copy with mate, I will definitely use copy with mate along the line. Let's say there's I will use copy with mate very soon now, very soon. So you understand what it means. So the next thing is for me to insert a component. So I'll go where I save this component. Again, let me show you something, sir. If I click on insert a component here, there's a document open that actually there is here. Peradventure, I just finished designing all these parts. I've not closed them on my Solidworks. All those parts that is recent, that is still open, will be here. So you can easily just drag and drop. You don't need to go back to the real file locations where they were to bring them in. So you will find them. You don't have to browse it out. It will automatically be here. Let's say I've opened the part before, it will be there. So supporting column is the next thing, and I'm bringing it in. So this is the column. So that's a threading on this internal threading here, where actually the main thing used to hold it down. The underneath here was actually welded to this inside. So my job now is to actually make this O to this O. Now, if I have such kind of mate, is called concentric mate. You have a circular something that you want it to enter a circular something, and you want all of them to maintain the same center. Concentric, like a common center, concentric, common center, two circular objects that must share a common center. Like you have to use this concentric mate when you are talking about anything rotating, any part of the machine rotating, because the crank and the crank shaft must have a center, a common center. So that's the kind of concentric locations, which is what I'm going to do again now. Just click on the surface, or if you want to use mate from here, click here and click here. Then Solidworks will bring it to that center. Now, I'm not rushing this class at all. You can see, it cannot move anywhere again. It will maintain that center. We are still in very simple mates. Concentric, coincident, parallel, they are very, very common mate around. So my next job is to actually ensure that this place, this face now, lies within this space. Inside.
Yeah.
So there are several ways of going about it, but I don't want to rush this class. I really mean it. I will drag it down, then I will do something like section, so that maybe we can see what is inside, and that might guide our meeting. Because if I want to do it, I don't actually have to section it. I know there's another way to balance it. So I can access this surface. That's my why I section it. So if I click on this surface, a pop-up also come up that says mate here. So I can just use this. Of course, I will be using coincident mate now because I need this surface and this surface to be on the same page. And you can see the moment I put that, Solidworks automatically recognizes that what I needed is a coincident mate. I will be as slow as possible, and I will allow you to also do this while I guide through on how to go about it. So once I'm done with this mate, I marked it. So I can actually comes out of section. And this is it. You cannot have any other movement to do except rotating.
Yeah.
That's the only movement you can have. But that's not a concern to me. I can actually make it not to rotate. So I'll go back again. I will delete it. But let me first of all demonstrate that I can rotate. I think that's very important. Can you see?
Yeah.
So it can actually rotate. So concentric rotation mate does not mean that an object cannot rotate. It just means that they share the same common center. A circular object, yes, a cylindrical object share the same centers with that. So if I go back to that mate, again, just follow. So this is it. Now we have two components in my assembly. Please, 1 minute, please. Hello, madam.
Hello, sir.
Yeah.
Yes, sir. I've already got into the chair.
Okay.
The next thing is to think of how to get this thing to Apostle. Have you?
Yes.
I think it's for Apostle or for the ministry.
It's for the ministry.
Okay. Isaiah.
Okay, it's clear now. Yes, I've seen it.
Okay.
Yes, I've worked on it. All right. Sorry, it's an important point. I need to.
Yeah, it's okay.
So, in this assembly called assembly 1, we just import two components there: the base and the very first supporting column. Base 1, supporting column 2. These are the two components I have brought in.
Yeah.
So if I open the design tree up from here, I will see everything about how I made this play in the base. Then the most important thing what I actually want to show you is if a new folder that wasn't there in part comes up called mate in assembly 1. Every mate that this component has engaged in, you can find them here. The very first coincident plane with its front plane that was there, and it will be highlighting it on the main thing here. So that's the very first, the second one, and the third one for the right plane. Then the concentrics, and the coincidence. All of them. So peradventure, I really want to work on any of these mates. I want to delete any one of them. I just have to come in and delete it. That's 1. 2. There is another one that has mate, the general one, This one, all the old mates in the old component.
Yeah.
So, and SolidWorks has a way of referencing them. Like your mate 1, your mate 2, your mate 3, your mate 4, you might, along the line, you will be designing a machine that you might have about 600 mates.
Yeah.
So you can find any one of them under this place and work on it. So I want to look at that concentric mate that was between the supporting column and the base. And I want to show you something with it. So I want to edit the mate and show you. Now, there's an advance, a little bit of advancement from 2014 upward called lock rotations. Let's say the flywheel supposed to be connected to the end of the crankshaft, and both of them should be moving together.
Yeah, that's in rotating.
Rotating. So that instructions, lock rotations, make it fixed together. So I will just come here and upgrade it and say, I need a concentric, but under that concentric, lock the rotations.
Oh, okay.
So that guy cannot rotate again. With this, I have upgraded the mate now. This will not definitely rotate again. Have you seen? The component selected is fully defined. It cannot be moved. Now our assembly now is fully defined without any ambiguity. So the next thing for me is to actually bring in the remaining 3 supporting columns. Are you with me, sir? Is it clear?
Yeah, I'm with you. Yeah, I'm with you.
This is where copy with mate now comes in. There are standard mates that comes with this guy. Now, copy with mate, what you do is that I'm copying these components and I'm copying the mates that are with it.
Okay.
So you see, it's one of the tricks that make the work faster. But I will do one now. This is not actually the class that I'm supposed to have talked about it. Let's follow the process easily so that I will not. I just want to stay on a very, very simple way. Now, I can decide to go and insert a component and bring this guy back, this supporting column back. But I will not do that. I will show you a fast click towards that. Hold your control key, click on that, and drag the new one out. So you have the second one. I think I'm seeing supporting column 2. Yes, okay, it's there. It's simply because I'm a section. So let me do that again. Hold control key, then drag the new one out. So anyone, even if it is the base, you want a new one, just hold control key.
Yeah, you can drag, So I was trying that this afternoon.
Okay, you are trying it this afternoon.
Yes.
All right. So I click on the cylindrical surface and I do mate again. Then zoom into this place. Then I mate it. So okay. So the next mate for me is to actually mate it to the base of that. If I don't always want to do that, another simple way, I can come to this surface. Sorry, I select that edge, but that's not a problem. Since I'm teaching somebody, I need to do everything right. So if I select this surface and I mate them together, did you know that it actually did the same work?
Yeah.
You can imagine it.
It will move out,
Each of them are of the same length.
It's the same length,
It doesn't really matter. Instead of me to be sectioning again and again. So now, let me do one single copy with mate. So I click on this and I see option copy with mate. I actually right click on it. And I see option copy with mate. Here. And I click on it. He said, okay, which component did you want to copy with mate? I said column 3 in my assembly. He said that column has 2 mates. A concentric around a hole, 1 hole, and a coincidence around the surface. So you can see the very first mate there, concentric. So I'll click the next hole. I want the new one to be. And he said there is another coincidence on top of the surface. I say the same surface. Then instead of me bringing a new component, is there. I'm not just bringing this new component, I'm copying every need that is with it into the code. It might look like a magic. Now is it clear? Let me try another one, but I really don't want to cause a confusion here. By the time you get assembly and used to the assembly very well, you understand why that is needed. It makes the work faster. It's one of the. So I'm doing concentric with this surface. Then I marked it. Then the second one is to ensure that this height here is flushing with this height. So and we have this. So our assembly now has 5 components. 1, 2, 3, 4, 5.
Yeah.
Now, the next thing is to bring a plate in here. Let me bring a sample of a brake pad so that we can reason along. Okay. Actually, I designed the machine to produce a brake pad for Nissan Pathfinder. A car, Nissan Pathfinder. This is the brake pad. Now, the brake pad consists of 2 parts.
No.
Nissan, okay. Are you?
Okay, yeah, I'm with you.
Nissan Pathfinder brake pad. The brake pad consists of 2 parts: the metal base and the abrasive head.
Yeah.
So this is the metal base produced separately without abrasive head. So the aim of this machine is to actually ensure that the abrasive head is glued to the metal plate. So the metal plate will be cut by plasma cutting. This was done with oxyacetylene.
Yeah.
This was done with oxyacetylene cutting. So the aim of the machine is to gather the biological agricultural waste and use to make this brake shoe and the abrasive materials. Now, this is how the machine will work. That hole on this surface will be the one that this will enter and drop inside.
Okay.
So the next layer will be a thicker layer that is sufficient, that has this hole, the abrasive materials on it.
Okay.
So when this comes in, then we now have another part that is going to press this, compress it. Now let me explain something again. A careful observations about this shows that the plate is a bit bigger than the shoe.
Yeah.
In size. So
yeah.
I decided to call that. I decided to use a foundry technology here, a foundry term called the cope and the drag. There's type of the which is called the cope and the drag. So
yeah,
I will introduce the next one, the new component that I want to bring in now. So, which is the C mode, which is the cope mode. I just call it C mode. I use that to represent the cup in my own way. So my own job is to first of all ensure that this circle aligns with this circle, shape, and this circle. Yeah. Any two of them that are aligned.
With any of them, yeah.
Along the line, when I was teaching parts, I taught something how to transfer a sketch from one part to another. I did that when I minimize the window and I transfer a sketch to the next part.
I remember.
Now, if you don't do that here, I can bet it with you. If this O and this O are misaligning by 0.1 mm, Solidworks will raise a voice and tell you that it's not possible. So if those 4 O's were not properly aligned, and the interesting thing is that in the real life machine, it wasn't aligned.
Oh, really?
Africa does not have a good technology to produce something. I'm telling you, as small as that is, you can't produce it.
Yeah.
In real life, what did I do finally to solve that problem? Let's just go to and see what happened. Back to WhatsApp. because I communicate with the guy that owns the job. Here was some. Where is my? Okay, yeah. So you see what I did to solve the problem. I need to carry angle grinder and expand the hole. You see, it wasn't perfect as the way it was on Solidworks.
Yeah. Oh, okay, okay.
You see the
Oh,
hole.
okay.
It's,
I can understand.
it's bad.
Okay.
Seriously, you can't. This is just some.
This is yeah. I understand why you said African
We are
Africans are not up to.
seriously, we are
I get
seriously bad. These are the supporting
yeah.
columns, the four of them, and
Mm-hmm.
it's too bad. This is too bad. I have to now carry angle grinder and be cutting it. And I'm telling you, cutting 10 plates with angle grinder is something that is you don't want to try.
Yeah.
It's
It's
extremely
difficult, yeah.
stressful.
But why did you not use a drill?
Drill that my own drilling machine here is a hand drilling machine. I can bring it for you. Cannot actually accommodate this drill.
Okay.
Let me give you an instance. The drill bit that will do this job is actually 32
Yeah.
32 drilling bit now cost 9,000 naira in market.
Really? 9,000 naira.
Yes, in Nigerian market. Now,
Okay.
the old job was this
So
old
what did match up to? Oh, okay, I get it.
this old machine does not even reach 60,000 naira to produce it.
Okay.
And
So how much?
the guy is still owing me 17,000 naira balance till today. So by the time you now carry 9,000 naira out of the 30 something thousand and buy just a drilling bit.
It means that you're doing cost 360 job.
So
Okay, I understand.
it's not something that you want to try at all. So
Yeah, I can understand.
it's that bad. But my main focus here is this is not hard at all. Let's be sincere with ourselves. I was looking at something as very simple as small in Nigeria yesterday. I can even show you. And I feel ashamed of my country that even in this country, we cannot produce this. Just give me 1 minute. Let me show you something. This particular component is just a plug, like for normal laptop, all these things. It was so bad that I can tell you that this thing is imported. We need to talk to ourselves, Africa. Did we have sense? Did we have sense at all? As small as this is, I am so certain that is 100% certain that there is nowhere in Nigeria where you can produce this. So even if you give this to guys that are cutting, they will cut something that later it doesn't work permanently. The moment I brought all the plates at home before I started welding them together, I already know that I'm going to have a problem because the holes were not aligned. They were not matching. And I can't be the OCR settling guy, be the laser cutting guy, do everything myself. So when I was saying that if you are a designer, you need to actually have a knowledge of what is possible in your market. You just design one fine machine that is working on Solidworks that can never be produced. Please, are you with me? Hello? Hello? Wow. Let me check chats. All right. So there's a need for us to know the knowledge of what is applicable in our market. And so I'm taking a concentric mate here to this. then map it, then to this. If I do only these two, I believe I'm fine. So this is fine now. So now my path can go up and down within this. So within this. So this is the gist. The metal plate comes into this.
Yeah.
This guy was lowered, and the whole agricultural waste will be packed into this place. Then the deep part of the mold, which is the drag, come and press it down. That's the old gist. Now, but here we have a pit issue. This guy is supposed to remove. So of course, just a coincident mate cannot do this job. Because if I just use a coincident mate, it will just remain in the position. I know the right mate to use, but for the sake of the progress of this class, let's use coincidence. There's a mate that gives us the ability to do a minimum and a maximum movement of a part, even a linear movement. Yeah. I don't want to add things that are extremely advanced. So we have this now. So it's covering the whole. The next thing to bring in is the next component, which is the D mode. So is this part now that is going down to do what? To press the whole, the whole thing. So of course I need to turn it upside down if I really want to do the job. So what I will do is to do 0 concentric mates. So I think that O should be corresponding with this place. Then flip upside down. So there are 2 things here. Just follow my cursor, flip mate. So I'll just change alignment like that. It knows that it needs to turn it upside down. So then the second one, I'll mark the mate I'm done. Do the second O. So we can confirm from under whether what we did is correct, which is correct. So this goes down this way. So let me just maintain. I'm introducing a new kind of mate. Now we have done concentric and coincidence. So I want to do distance mate now. Let's say I want to maintain a certain distance between this face and this face. I really don't want concentric, so I'll come and choose distance. This is distance mate. This is coincidence, this is parallel, this particular, tangent, concentric, log. This log is different from concentric logs. This is different from concentric log. Concentric log ensures that 2 rotating objects keep rotating together. This log means that the way they were, let them remain that way. That's the way this log means. Like you fix something together permanently like that, you weld them together that way, irrespective of the way they were touching. So I'm introducing distance now. So if I want to make it 100, for example, that's 100 mm. If I want to make the 2 surfaces to have 50 mm distance, that's 50. If I want 10, that's 10. So if something will have distance between each other and they will be facing each other this way, then distance mate is the best mate to do. You can also flip the directions. Let's say it needs to go down more than that. So you just say flip the direction, it takes it down. If this is clear, keep taking it in the other way around. So that's the other way around. So peradventure, that's what you want. Let us remain this way. Of course, this is not the best mate to use here, but for the elementary class, that's now. I need to bring an hydraulic jack into this process. So now hydraulic jack, of course, is an assembly. So that would be bringing in assembly in assembly. All right. I'm not even seeing it as the hydraulic jack. I'm coming. I know what to do. there's an easy way to go around it. So let me just bring the old machine somewhere else, so I can easily bring the assembly, the jack.
Oh, okay.
And this is where grab card really here. Let me open secrets for you. You don't have to, because I want to design the brake pad molding machine. Now suffer your head, say I want to design hydraulic jack to standard to the way it was. No, just go on grab card, pick the component that has been already designed to start, and bring it to your assembly. Of course, this will definitely be on my download. I did not design the hydraulic jack again. You should how much pay me that I will now be suffering my head to design the hydraulic jack for me. So it doesn't worth it. So for me, I will just look for the hydraulic jack here. So assemble hydraulic jack. So it was an assembly inside the assembly. You will always know the symbol of an assembly because it has a blue on the step. So for that, let me just demonstrate some things to you so that you can see that despite the fact this was not constrained, have you seen? It can actually move. There is a mate in between them, but it can move. I think I've upgraded this work on GrabCAD. It should be on my GrabCAD. This particular.
Oh, really?
Yes, this job is on my GrabCAD. So inside the components, you see now that the sub-assembly hydraulic jack is now showing as an option. I don't want to look for it. So because I just opened it recent, so it knows that it's there. So I just bring it into the assembly place. So my next job is to align it to be at the center. Again, during fabrications, I find this a bit hard. The base of hydraulic jack is made with a cast iron, and the main thing is mild steel. Now, of course, welding cast iron to mild steel is a bit challenging. You will need a cast electrode to be able to do that. So this is also a challenge. Cast electrode expensive than mild steel electrode. All right, so let's make progress. So this surface is expected to mate this surface. It's expected to mate this surface. If we are concerned about how this O will be aligned, this is the O here, aligned to this O here. Of course, if you don't do your work well here also, you have a wrong result.
Yeah.
Because it will still tell you that it's not possible for you to align those O's. Of course, I modified this assembly, this jack. I did a little bit of modification so that I can work for what I intend to do. So with that, I'm good to go. With this. Then, of course, the last part, which is the top, the cover. I will start the last one, browse. Wow, it's taking me to the assembly track. So let me do it. Let's start project files. The top member. So concentric mate to concentric mate. Mark it. Then concentric mate to concentric mate. Mark it. Then finally, this surface should be touching this surface. Then, with that being done, we are good. Hello? Hello? All right, are we still very much together? This is actually how to go around the assembly. There's something I want to introduce here. That's why I need you to be active. I just want to show you one thing, then I'll just quickly send all these files to you on WhatsApp now so that you can give it a try. Hello? All right. So what I want to do, I will send you the file, but there's something I want to teach now. I'm sending you the old files on WhatsApp so that for the practice of this class, go around it. That's what I'm trying to generate. So it's entering now on WhatsApp.
Yeah, I've seen
So
them on WhatsApp.
here's the Untitled Chapter. I'll get it where it was. And I'll send it. All right, let's do the last thing now. Then we'll switch over to the side so that I can give it a try. Then we'll know that certain mate has been covered today. I want to teach something called Solidworks toolbox. This design library and toolbox. What are these? There are standard parts. Sometimes I talk about it. There are standard parts that you don't have to go over and design again. All bolts, all nuts, all O-ring, gears. You don't need to go back and design them. They were already designed by Solidworks, and it comes with Solidworks. So all you just need to add them in, and I need them in metric. So what I need is bolts and nuts.
Yeah.
Now, this will definitely be introductions to them because they are actually called smart components. So I'm taking an hexagonal edge bolt. So all that I have to do is to shift this to this.
Mm-hmm.
So it may just be a bit slow on my laptop. I don't know if you can see a symbol on my laptop, a flat and a blue.
Yeah.
Now, we will do this in our class. It's called smart components. Smart components are those components that can recognize a feature by themselves and knows the mate they should mate with that feature. So SolidWorks designs all their toolbox with a smart components concept. So once you see a circle, a hedge, or a bolt and nut, he knows that he will automatically introduce a concentric mate around the edge and introduce a coincident mate with the head of the bolt to the surface. So what I just have to do now is to ensure that my head is active.
Okay.
That's why I turned my design into the directions of me bringing it in. Then the moment I did that, SolidWorks also know that it is M8 that I needed.
Okay.
Because it knows the diameter of the hole in question now. So it automatically puts the right bolt. But if you want to change that bolt, you can change it to something else, maybe M10, M12. So if you are okay with M8, then it will ask you, is it washer faced? What is the length you need? What is the thread length you need? Is it a simplified that thread display? You can have a cosmetic or a schematic. I will explain what it simply means. Simplified means that it's not going to show where the thread is, and I will explain why we need all this. Cosmetics means that it's going to show it, but it's just going to show it just like a design, just like a black where the thread is. while the real one will show the thread. But the moment you are putting thread, you are putting all these things, the amount of graphics memory that your laptop has will be reducing. When you have to put a lot of bolts into this work, so then the system will begin to slow down. So that's why, in order to save from those things, so Solidworks decided to, okay, just put a simplified. Now, there is difference between thread and thread length, the length of a bolt and the thread length. So you can have a bolt that is as long as my hand like this, that it is only from here to here there will be thread. The remaining will just be a normal major diameter. So that's what we mean by the thread length and the thread itself. So once you are okay with all the selection, just click on yes. But if you click on yes, it will not take it away. You see, you can just automatically be adding it to where you want to add it to. So when you see this symbol, it means that the whole smart components is active. It has been able to recognize an edge. So I know it's been able to recognize an edge. Once I'm done with where I want to add both and both, I'm good. Then I automatically add it. So this was the one that I added wrongly. I did not see it right. So I deleted it and we have the assembly done. Is this simple. So let me open up to questions and concerns along the line when we have done. We just use basically three mates: the distance mate, the concentric mate, and the coincident mate. That's basically the three things we did. The first thing we try to do is to ensure that our first component, we make it float. Once we made the front assembly to the front of our component, the top plane to the top plane of our assembly. When we did this, we need to put in our component and we are laying them to the way they're supposed to be. So at this junction, I've sent you the whole file. The last one, which is the hydraulic, I will send it now. So I'll wait you to be able to share screen. Then let's give it a try. I'll still be here looking at how the whole things goes.
Okay.
Then participants. I don't even know where you find that options of making everybody to share screen. Well, let me just make you host instead of stressing myself.
Okay.
Make host. So I will send the assembly, the hydraulic jack files now.
Okay, so I've made multiple share screen.
Okay, all right. I think that's fine. Let me quickly look for where this file is. Just okay.
I've shared my screen.
Okay, I want to send you this now.
Oh, okay.
The hydraulic, the cylinder is sent now. If I didn't send all the whole components inside this, you won't be able to access it. So
yeah.
It's done now.
Wow, so many of them. Okay. Let me transfer them to. Okay. The sending is in progress, so let me.
They say what? Okay.
I'm sending, so
Yeah. No, to send it to your laptop, Abi.
yeah.
I understand. So make it float. That's the first thing. Right click. Float. You see float option. No, go down, float. Yeah. Now it can be moved. Then we made the front plane to the front plane center. Yes. Sorry. Front plane to front plane. You will click on mate first.
Yeah.
Assembly mate here. Front plane to front plane. Yeah. Then you mark it. Right plane to right plane. No, don't go away, don't worry.
Oh, okay.
Right plane. I did those going back and forth so that I will be clear in explaining it. That's why I did all those things. You mark it once you're done also. Then top plane to top plane.
Oh, okay. So at any point in time, you have to do this.
Yes. So that you are accepting the mate.
Oh, okay.
Now, the reason why it's not going away is because there is a function there that is actually pinning it. There is until when I'm done. That's so. If you want it to be going and back, you just unpin it. Then that one after undo. You know, you have mark, you have cross, then you have undo, then you have unpin.
Yeah.
So now that you are done with all your mates, you can mark it. That you are done now. So if you fully divine, there is no issue.
Yeah.
So the next thing is to insert component. Assembly, insert component. Then those are files that you open. Now they are the ones showing there. Now the stand, supporting column. Okay. So supporting columns, then bring it in. Yeah. Just drop it here. Then concentric nodes. Yes. Just click on the cylindrical surface. Yeah. Your laptop is good. There's something I saw now. Yes. It's even, you should just mark it. Mark it. No, you have to mark that mate first. Accept the mate. The one you just
Okay.
Then they are sectioning. No, leave mate. You have to leave mate entirely. That's why it's not showing. It's not active. Then sectioning it.
Okay.
You can change the plane of section. You want to section it so that you can be seeing this. Come to section, come down, yes. Then where you have section 1, then click the next one. Click the next one. That's it. So you can mark it that way now. It's too much. It's okay like that. No, you will see it like that. Just mark it. Mark section, don't worry. You will see it. It's clear. Then turn it. So that turn the whole screen like this. Turn the whole project like this. Like this. Like this. So that you can access the base of this guy, you need to see the base of this shaft. That supporting column, you need the base.
Yeah.
Turn it so that that's the turn I'm talking about. All right. Mate. No, it's the base you need. Yeah, that's it. Click on it. Then click on it's up, except if you want to do it that way. No one. Is that the face you want to use? Let's go. No one. Let's just go. No problem. Let's go. It's okay.
Okay.
So maybe along the line I will do edit mode also, so that we can edit any surface that we don't like. Just mark it.
Okay.
Then, yep. So hold control key, drag the new supporting column out. Hold control key, drag the new one out. Wait. Hold control key and drag. You will click your mouse down. It's out. You want to bring all of them out once. All right. No hala. All is well. No, yes, that's the next one. Start with wait. Just calm down small, sir. Calm down small. Just follow my instruction. Just calm down small.
Okay.
Go and click on that surface again. Click on the surface again. It will give you a very on the surface of the new one you want to make. Wait. Click on it. Be careful. Just do it gently. No. See. Just click on this place. See my hand on the. Just click on it. Be careful. The mate option is showing for you. That's why I want to show you. Instead of running up and just click empty space again. Click empty space. Click it again. And be careful when you just click it. Click it again now. Click on that surface again. See the pop-up screen that shows. Go to mate. Instead of going up and down, it's there. So click on the second surface. Then mark it. You are done. You can also, there's also pop-up for marking here. All right, no problem. Then, yes, it's concentric now. Then take the surface to surface, then top surface now. Okay, you want to do this next, yes. Your mate is still active, fine. So you have clicked it now, you are correct. No, you have not clicked the second O on the base. You just select one part. Yes, mark it. Then the last one, yes. Good, mark it. So then the top to the top now, the top to the top. Top to, no, you can't reference it to that one. Reference it to the one that is existing, that you did well before. You are not getting it. You have to reference to that one that you did before. Yeah, I like that. Surface. Surface, not edge. You are clicking edge. Clear the selection. Right click, clear selections. Then surface, yes, that's the face. That's the face. Yeah, fine. Let me teach something. Mark it. Let me teach something here. That box where you have your mate selections, just go towards that place. There are two symbols on by the side. Click on the down symbol. No, the down one. Yeah. It's called multiple mate.
Okay.
You know what you want to do now is that there is a face. You want the two objects to be equal. So instead of doing it one by one, I want to teach you that you can do both of them once. So click on the one that is standard first. Click on the one that is standard first. That surface. Then click on these two now. These two that you want it to rise up. And click on the second one. So instead of doing it one by one, if you have a multiple mate, just mark it. So if you have multiple mate like that, instead of doing those three, one, you just repeating once. So insert the new components and get it done.
Okay.
Yep. Yeah. Mark it. Mark. There's always one mark that is showing for you pop-up. Now, there's a bit confusion here, Abby. There's a bit confusion here. Just calm down. Let me explain. Just mark the old mate. Take the old mate out. Let me explain. Yes, you can close it. Close mate. Don't worry.
Okay.
Now, go and click on that flat plate and move it. You will see where the issue is. On that flat plate, you just introduce now and move it. Move it so that it will be clear now.
Oh, okay. Oh, okay.
It was
Only one side.
coincidence that the thing looks perfect.
Yeah.
It wasn't perfect. So you cannot do your mate now. You can do the right way. No, you don't need to make it perfect. Just leave it so that you can click on it. So click on the surface. No, don't use edge. You can turn it. Don't worry. Click on the surface. Don't use edge. Edge will later create problem. Okay, that's wrong. Go. It is the face you are clicking. So you can delete. No, delete clear selection. Just clear selection. Don't worry. Clear selections. Yeah. Or delete. Then I believe what you want to do is surface of this.
Yeah.
This first and the O in question second. That's it. So mark it. You are good. So for you to see what you have done, you can click on that mat and that flat plate and move it. That's why you have made it work. Don't worry. So you see what that simply means. So you can do all this for any of the components at any point in time. Eventually, I just want you to see it clearly. That's why I said you should system that time. You can do it even inside it and see what happens. So sure you want it to touch each other, then let's do the last mate. No. If you drag it, you won't be able to click it though. You still need more mates, sir, to make sure that that plate is touching like this.
Oh, okay.
So drag it up, drag this guy up.
Up.
Yes, drag it up so that you can click the surface under the ear, so that you can click here, so that you can touch ear.
Okay.
Turn. Mr. Guy, you like shortcut, it's fine. Head to head, it's fine. It's fine. So it's to insert the next component now. Yes, a shortcut is fine, it's nice, but
but you always say you should go the simple way now.
You use Python also. I'm seeing Python on MATLAB, Microsoft Edge.
Oh yeah, so many of them.
Okay, that's nice. Let's do concentric again. Don't worry, here I will not crucify anybody. Just do as the Lord give you power to do, because normally that shape should coincidence with the shape under. That's the right one. Zoom in, if you zoom in the here to appear, it's okay. So then you now flip the mate. Flip the mate so that it will turn upside down. No, down, down, down. Yes, mate alignment. Mate alignment. Mate alignment is there. See. Second one, exactly. Then you mark it. Marking just means that I accept the mate.
Yeah.
So select the next two ones. Can it be that one? No. I just want it to show you the error. Just try it. It will show you the error. Don't worry. There's no possible. Let's just check. Let's test Solidworks smartness. Just put it. Let's see. We tell you that it's not possible.
Mhm.
You did not select the right one.
Yeah, I get it.
Don't worry, it's there. Can you see? He tell you that
Yeah.
it's not possible.
Okay.
So turn it around so that it will be easier. You can just turn that flat plate. No. Okay, rotate the component. All right. This thing, you don't even need to go and click that plate. Just normal free drag. Just click on it and drag it to turn. You're giving yourself trouble. Don't worry, mark those ones. Mark it. Don't worry. Just click on it. You don't need all those ones. Mark it. Just click on it. Click on that surface. Bounce like this. Turn. Turn your mouse. Don't worry. Just move your mouse. You see that you have selected the wrong thing. It cannot work. There's no two about it. It cannot work. You just have to change that. It can't work. It can't work. So let's edit mate and let's go. We need to edit that mate. Wait.
Yeah.
We need to edit that mate. Locate the columns. Wait. Just click, close it. Let's follow through. The last thing was go to D mode. D mode. Click on that drop box. D mode. That small triangle, very close to D mode. Yes. Mate in assembly 1. Mate in assembly 1. Open it up. Then right click on it and say delete. If you want to delete it, if you want to edit, so we can do the mate again.
Okay.
Carefully just set it well. No, uncle. Cancel, yes. Select the surface of stuff. Yes. That thing wasn't square. That was the problem. It wasn't square. It was rectangle. Click on the white screen, sir. Click on the white screen. Then, Jesus. This guy just want to use this thing to move around. You can actually look at it and knows whether it's right or wrong.
Okay.
Oh, it's anything that works for anybody, let them do. Yeah, I'm waiting. Yeah, rotate.
Okay, so this way now.
It's fine now. There we are. Start your. Yeah. Mark it. Do another one. One just to balance the movement. Then mark it. Then let's do the distance between this surface to this surface. No, click on the first surface first, maybe the one on the base. Click on that surface, yeah. Then click on the next one, turn it. Turn that drawing bit like this. Click on that surface, fine, that's the right movement. So you need distance there. So go back to this place and click distance. Distance is on top angle. Lock, you see lock? Then the next one to lock is distance. Click on it. Click on that lock distance. Then input the distance you want. 20.
Okay.
That flip dimension that I did that time, you can change it for.
Yeah.
So once you are okay with it, then the next thing is to insert the next component, mark it. Let's insert the next component. Like mark the old mate out. We're not mating again. Let's insert the next component. which is hydraulic cylinder, and that jack. I sent the jack just of recent now.
Oh, okay.
On WhatsApp.
Just trying to.
Okay.
I have to send like them one by one.
All right, no problem. Let me be sending assignment.
Okay.
Just find. Anyone here that is simple? Hello? Yes. Emmanuel, mo wà ní church dey call me. Ṣé mi ò ní lọ church ni? Call me in the evening. We'll talk.
I think the final one is coming. So, hello. 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 It's muted.
Sorry.
Okay.
I moved myself. I was talking. I said I was trying to send the assignments to you on WhatsApp.
Yes, I've seen the new one.
Yes. So you can give this one a try. Even just if you can't see the hydraulic jack, you have done this one, then let's do I think that Solidworks toolbox finally to add both and not to the top. So though we'll definitely be doing it along the line when you need to add a lot of things. Can you just let me turn you see the way I turn the head this way when I want to introduce center board and this, then press it down. then move it.
Yeah.
So then you now zoom it in.
Okay.
So toolbox, then we can go to design library now. Yeah. Then toolbox. Add in now. Just click on add in now. Add in now. So asymmetric. Yeah. Then bolt and screw. Check in by more. So then hexagonal head, yes. You just drag it, you click on it and drag it to that place. Yes, you see when the symbol shows that SmartMate is active. It's not active now. Carefully observe it. It's a concentric and it's like a head that has like this and a flat plate, something of this nature. Once it's shown, you know, because of zoom issue, I might not be able to capture it very well. But once it's shown this,
Yeah.
yes. So it's fine now. Then you mark it as M8. You can just mark it. Then it doesn't go ahead. Oh yeah, keep going to the next one. Yes, it's showing now. Yes, that's it. Then we'll move in to the next one. Yes. Then the last one.
Oh, okay.
Yeah, you can now press escape or cancel it. Press escape on the keyboard or close it. So if you have multiple places you want to have both and not after you have finished your design, you just be going like that.
Yeah. Oh, okay. I'm putting it up. Oh, okay. Oh, this one is now downloading now.
So I believe we have started. I will keep sending assembly files that you can practice along with you.
Yeah.
That so
I'll put it together.
taking care of introductions to assembly has been done today.
Yeah.
One meeting on Wednesday. Share.
Yeah, sure.
The meeting on Wednesday. We had more mates.
Okay.
Distance consent. Then coincidence has been done. Then well, this will be the one of the most ones we'll be using along the line.
Okay.
The other advantage are also fine. It's necessary for you to know them: the part mate, the width mate, the symmetric mate, a lot of them. They are there.
Okay.
Can give that one a try. Let's talk on WhatsApp how it looks like. Keep working.
Yeah, I will work on it and send you the feedback.
All right, sir. So you are welcome.
All right, thank you, Isaiah.
Have a nice day, sir.
Yeah, you too. See you.
Yeah, bye-bye.